the most successful spacecraft ever built, was murdered. And the reason was itself. In 2017, NASA pointed Cassini directly into Saturn's atmosphere and let it burn apart. 11 of Cassini's 12 instruments were still working. It was still transmitting. It was still doing science. NASA destroyed it anyway, because the spacecraft had discovered something so important that it had become a threat to what it found. Cassini arrived at Saturn in July 2004 after a 7-year journey. It was built by NASA, the European Space Agency, and the Italian Space Agency. It carried a probe called Huygens that landed on Titan. It mapped Saturn's rings in detail no telescope on Earth could match. It watched storms erupt across Saturn's atmosphere and tracked the behavior of dozens of moons. For 13 years, it did exactly what it was designed to do, and more. The mission was extended twice because the spacecraft kept finding things worth staying for. The problem was what Cassini found on a small, ice-covered moon that most people had never heard of. Enceladus is tiny, about 500 kilometers across. Before Cassini, it was considered a frozen, geologically dead object. Then, in 2005, Cassini flew close and saw something no one expected. Plumes, jets of water vapor and ice particles erupting from fractures near the moon's south pole, shooting hundreds of kilometers into space. The spacecraft flew through those plumes. Its instruments tasted the material directly. What they found was salt, organic molecules, carbon dioxide, and later, on subsequent passes, something even more telling. Molecular hydrogen, the chemical signature of active hydrothermal reactions happening on the ocean floor beneath the ice. Enceladus was not dead. It had a liquid saltwater ocean in direct contact with a rocky core, with chemical energy being produced at the boundary. It had the basic ingredients, water, chemistry, and energy, that on Earth are associated with environments where life can exist. Cassini did not find life, but it found conditions that could support it. And that changed everything. Because Cassini was not clean. No spacecraft launched from Earth is. Despite extensive sterilization protocols, it is practically impossible to guarantee that a spacecraft carries zero microbial contamination. Hardy terrestrial microorganisms, bacterial spores in particular, can survive the vacuum and radiation of space for extended periods. As long as Cassini had fuel, this was manageable. Mission controllers could steer it, adjust its orbit, keep it away from sensitive targets. But fuel was running out. By 2017, Cassini's propellant reserves were nearly exhausted. And without fuel, its trajectory would slowly become unpredictable. Saturn's system is not gravitationally quiet. Titan, the largest moon, exerts significant tidal influence. Over months and years, an uncontrolled spacecraft's orbit would shift, wander, and eventually risk intersecting with one of the moons, including Enceladus, a spacecraft carrying Earth's biology, drifting uncontrolled, with a non-zero chance of eventually crashing into a world that might harbor conditions for life. That was the scenario NASA could not allow. The decision was made in 2010. 7 years before the end, Cassini would be deliberately guided into Saturn's atmosphere and destroyed. Saturn was the one place in the system where disposal was safe. The only way to keep Cassini away from the moons was to remove it from the system entirely. The mission manager, Earl Mays, said it directly. Cassini's own discoveries were its demise. The final phase was called the Grand Finale. It was not just disposal, it was an experiment. Beginning in April 2017, Cassini was placed into a series of 22 orbits that no spacecraft had ever attempted. Each one threaded through the narrow gap between Saturn's innermost ring and the top of its atmosphere. A space roughly 2,000 kilometers wide. No probe had ever been there. Engineers did not know what was inside. They did not know how dense the particles would be. They did not know if the spacecraft would survive the first pass. So on that first pass, they turned Cassini's 4-meter-wide antenna dish forward, using it as a shield against whatever was waiting. What they found was almost nothing. The gap was near empty. Mission controllers called it the Big Empty. It was one more surprise from a planet that had been full of them. And then Cassini went to work. It flew closer to Saturn than any spacecraft in history. It measured the planet's gravitational field with a precision no instrument had ever achieved. It mapped the internal structure of a gas giant from the inside. It sampled ring particles directly, pulling them through its instruments as it passed. It detected the magnetic field at point-blank range, and it found something no model had predicted. Saturn's magnetic axis is almost perfectly aligned with its rotational axis, a result that broke existing theories of how planetary magnetic fields are generated. This was not a funeral procession. This was some of the most valuable science Cassini ever performed. The spacecraft was on a death sentence. It used the time to discover. The death route and the discovery route were the same path. The last orbit began on September 14th, 2017. Cassini took its final images of Saturn, Enceladus, and the rings. Its cameras were shut down to free bandwidth for the instruments that would operate during descent. On September 15th, the spacecraft crossed the boundary of Saturn's atmosphere. It was moving at 76,000 miles per hour. The upper atmosphere was thin, almost negligible, but it was there, and it was pushing against the spacecraft. The thrusters fired to compensate, keeping the antenna locked on a single point, 1.4 billion kilometers away. Earth. The signal Cassini was sending in that moment would take 83 minutes to arrive. Whatever happened next, the people listening would not know for over an hour. By the time they heard it, it would already be over. The atmosphere thickened. The thrusters pushed harder. On board, every system was still working, still transmitting, still measuring atmospheric density, temperature, composition. For a few minutes, Cassini was the first Saturn atmospheric probe in history, sending back data from a place no instrument had ever touched. But the air was getting heavier. The force against the antenna was building. The attitude control system pushed to full capacity, fighting to keep the spacecraft pointed at Earth. It was not enough. The spacecraft began to tumble. The antenna rotated off Earth. The link broke. Its last transmission was already in flight. A packet of data encoded in radio waves, moving at the speed of light across 1.4 billion kilometers of empty space. It had left the spacecraft before orientation was lost. The signal kept traveling. Cassini was already gone. 83 minutes later, the Canberra Deep Space Communication Complex in Australia received the final signal. The timestamp read, September 15th, 2017, 7:55 a.m. Eastern Time. But that was Earth's time. In Saturn's sky, there was nothing left. The spacecraft had been torn apart, vaporized, absorbed into the atmosphere of the planet it spent 13 years orbiting. The atoms that were once Cassini are now part of Saturn. If you like this kind of story, consider subscribing. There will be more.